In order to shred XML, you have to have some sort of XML to shred. So let's go ahead and write a query, create XML by streaming it, capture that XML, and then shred it back into a table. Let's start off by looking at all of the records of the customer table. It looks like we have 775 customers, and we have a whole bunch of them, like number 2, who we can't tell by looking at him if he's ever ordered from us or not. Mark Williams, has he ever ordered from us? Well, let's alias the customer table as cust, and we'll do an inner join on the sales invoice table, and we'll alias that as order. We better specify the fields they join on. It's the customer ID from both tables. Let's run this query. Okay, it looks like Mark Williams, yeah, he's ordered a few things from us. Lee has ordered 3 times. Patricia has ordered 3 times. Mary has ordered twice. Okay, that's interesting to note. But I can't tell, like on this invoice, how many items did Mark order? Did he order 3 different products at once or just 1? Well, in order to get that information, we need to know details about the sales invoice by joining to the sales invoice detail table. And let's alias that as order detail. And let's join that on the invoice ID from both tables. Okay, let's run that. All right. It looks like we've got quite a few records. It's shown us Mary Robinson first. Mary Robinson, on one single invoice, had 5 different products. What were those products? Product 76, 77, 70, 71, and 72. Okay, notice we have 6,900 or more records. We're getting a lot more detail here than we had before. Now let's say that our report is supposed to focus on customer ID 2 and all of his activities. Let's say where the customer ID of the customer table equals 2. Okay. We get customer Lee Young, who on invoice 943 only ordered 1 product, product number 72. You notice I had to do quite a bit of back and forth scrolling, so let's just focus on the fields we're interested in. We would like to see the customer ID, the customer type, the invoice ID, the order date, the product ID, the order details quantity, and that should just about do it. Okay, a very concise report. Customer number 2 on invoice number 943 ordered product number 72. Now, he didn't just get 1 of them, he got 4 of them. Now, I'm going to go ahead and put a top 1 up here. It doesn't make a difference for this customer, but let's say this report always wants to see the first product of the first invoice that a particular customer has ordered. So I'm going to put top 1 here, so it works just fine for other customers when we just want to see 1 record. Now, let's stream this as XML by saying for XML auto. And let's run that. Okay, let's see what this looks like. It looks like customer 2 was a consumer, not a business, and he has invoice number 943, and this is the date it was ordered on. It's product 72, a quantity of 4. Now, if he would have ordered multiple items, what would it have looked like? Well, in that case, let's check customer number 1, and let's go ahead and get rid of this top row limiter, and run it. Wow, look at that. Customer number 1 on invoice 824 ordered 1 item. On invoice 1027 ordered 1 item. But on invoice 1401, when that customer came back, they ordered quite a few products. This is a good time to see how XML implies relations in forms of levels. Notice that cust is the root level. It has many orders, and each order can have many order details. Therefore, we have the customer level, we have the order level, and we have the order detail level. When you go back to the query, remember that customer was the first table in the join, Order was next, and order detail was the last, and we put our fields in that order. Let's put it back the way it was. Let's go back to top 1 and say customer 2. This is the data we're interested in. Let's take this entire XML, and I did a Control-A to select all of it, and right-click somewhere in the middle and say Copy. Open a brand new query window, put in a single quote, paste it in, and another single quote. We will treat this as the XML document that we intend to shred into a table. SQL must first prepare the XML document. Which brings us to another interesting comparison. If you ask the question, how does SQL prepare XML documents for shredding? It's the same way a tailor will prepare fabric into clothes for you to decide when and where to wear it. If you went to the tailor with fabric that you picked out and said, "Can you please turn this into a shirt that fits me?" you would give him the fabric, probably give him some money too, and then he would say, "I'll have it done in a week." Now this person's working on a lot of other stuff for a lot of other people, so how's he going to remember you or find your shirt when it's done? Well, he's probably going to hand you a little ticket stub with your number on it. Now that number is hardly a replacement for a shirt, but that number gives you the right to access that shirt. So when you give SQL Server an XML document to prepare, it's going to give you a number back. And when you call on that number, you get your shirt. Or should I say, when you call on that number, you get your XML processed and ready to shred. Okay, here's our XML document. Now what we need to do is make an exchange deal with SQL the same way you would with your dry cleaner or your tailor. Hey SQL, I'm going to give you some raw XML, and I want you to process it and tailor it so I can shred it. While you're doing that, would you please give me a ticket stub or a number? Now SQL calls that a handle. A handle is a short abbreviation or a number that represents the data that you want that is stored in memory behind the scenes. So what you're going to have to do is an exchange. You're going to have to give SQL a document, and it will give you back a number. So we're going to have to declare both of those. Let's start off by declaring an XML data type. Now, we have an XML type, and we've given it the variable name of @doc, and we're going to set this doc to be equal to this XML. And we'll run it. It says commands completed successfully. All right, we've set the variable to be equal to this XML, but we haven't done anything. So now what we're going to do is we're going to declare a handle. And the handle will be like that ticket number that will represent this XML after SQL has processed it. So let's declare an @h for handle doc. Now this is just the number that represents the document, so we will set it to be an integer. Now we're going to call a special stored procedure known as SP_XML_ prepare_document. That's like telling the tailor, work on this fabric, turn it into a nice shirt ready for me to wear. Well, we're going to have to say we want a ticket number. See that output? That output should feed this integer and populate it so I can walk away with something that I can later use and refer to. And we have to give it the XML document. So here's the exchange. This is what the prepared stored procedure wants from you, and this is what it's going to give you back. Let's see what our ticket looks like. Let's run this. Oh, we get ticket number 1. I guess we're the first customer for SQL Server to start shredding XML on this particular session. Great. Now what we need to do is we need to start shredding it. And it's almost as simple as saying select star from, and then from what? Oh, from your ticket stub, which is 1. We're going to write a select statement against this handle. Now, I don't want to run the SP_XML prepare document again, and since I know the handle is equal to 1, let's make sure everything below these 2 dotted green lines runs separately. So let's go ahead and create another integer, and we'll call it inum. and it's an int, and let's go ahead and set it to 1. Now let's select all of the records from 1, but we have to use the OpenXML function before selecting it. And there's one more argument or parameter we have to pass into this, and that is, what level of data do we want? Now, if you look back up at this XML right here, you'll notice that the customer level, we have customer ID and customer type, and at the order level, we have invoice and order date, and at the detail level, we have product ID and quantity. So if you're interested in just getting the product ID and the quantity, you would specify to go to the customer order detail level. Let's say cust order detail, and let's run it. All right, there's our pre-shredded XML. It doesn't look pretty yet. All it tells us is the order detail level has a product ID with a text value of 72, and the quantity value is 4. Now that's not very pretty, but it's a lot of detail. So to really shred this the way we want, here's what we're going to do. We're going to say with product ID as an integer and quantity as an integer. Let's go ahead and run this. Ah, that looks more like the table formats we're used to. Let's run through that process again. This time, we're going to go grab an XML file out of the Resources folder. Let's go Open File, and in your JProco folder, you should have downloaded the resources, and there's this 3.2 OlympicsLab.SQL. Let's open that up, and there we go. Let's do all the steps to go ahead and turn this into a result set by shredding it. We have an XML document, and we want a number. Let's go ahead and declare the XML document. Declare @doc XML, and we're going to set it to be equal to this. Let's run that, make sure there's no errors. Okay, it all looks good. Now we're going to declare our handle. We want to get a number back that represents all of this prepared XML. So we're going to call the SP XML prepared document proc, and we're going to ask for our handle. At the same time, we give it the document. Now let's see what handle it gave us. This is a new session, so it should start over at 1. Yep, it says 1. Now if you were to run this again, the next handle would be 3. That doesn't mean that handle 1 is gone. It just means that it basically got duplicated. There's 2 places in memory, place number 1 and place number 3, that has the exact same XML. And at this point, you could shred either one of them because they're the same thing. So there's no need to run the prepared document twice, even though you might shred it several times. So all of the code below this select @hdoc, we can run as many times as we want. Let's go ahead and declare an integer that we will set to 1. And let's go ahead and select from this handle using the OpenXML. Now, what are we going to put here? The answer is our row pattern. And what we want is we want this data and all of this data. So we want to go to the Olympics level. Are they named the same? Yeah. So we will say Olympics. Let's go ahead and run this and see what it looks like. Okay, we have an Olympics name called 1984 LA, an Olympics name 1988 Seoul, an Olympics name 1992 Barcelona, and so forth. Well, let's make it a little friendlier. All we want is one field, the name. So let's say with name, and that will be a varchar max. Let's go ahead and run this. There we go. We've shredded that XML into a single field table result set. One more thing to show you, and that is this. We called this field name. Why? Because the attribute we pulled it from is called name. And oftentimes it's a good idea to have your field name match the name of your attribute or element that you're pulling. Well, what if I wanted to call it something different without changing the XML? In other words, I'm going to call this game name. Now, if I run this, we get no data because it's searching for game name up here. There is no game name. So how do I go ahead and repeat my field alias as game name, but tell it to pull the name field from the XML? Well, after your declaration, you say this is an attribute called name. So let's put that right down here. Run this, and you're grabbing the name attribute value, but you're giving the column the alias of game name. One more important point, and that is XML is case sensitive. Now currently, this works out really well for us. Why? Because capital N with 3 or lowercase letters of AME matches this right here. So as long as that matches, we're going to get results. What if I changed it to a name that I know didn't exist, like green grass? Well, there's no green grass or node up here named green grass. So if you use a name that doesn't exist, well, you're just going to get nulls. All right, let's change it back to name. And for all of our records, we seem to get the values we're looking for. Now, what if I went lowercase n in name? Run that. See? This name does not match this name because it's case sensitive. And also, if you wind up doing this, it won't work. All right, let's make sure we match it up perfectly. We've got name here. Now notice that your Olympics row pattern level has a capital O. What happens if I just mess up one of these letters? Lowercase o. What do I get? I get nothing. It couldn't find the level. Lab 3.2, Skill Check 1. Change the output from the Olympics resource file, Lab 3.2 Olympics.SQL, to have a different field header of game name as you see in this figure. Skill Check 2. Create the XML you see here. Take this XML and prepare it using the correct row pattern to shred just the 2 fields you see in this figure. Skill Check 3. Create the XML you see below and shred it into the result set at the bottom of this figure. When you're done, your figure should have a result set with 2 records and 2 fields as seen here.